Hi, everyone. Welcome to this first Full Stack Midday talk. My name is Andrew LaGrange. I'm the co founder of Full Stack. Business has been in operation for the last 9 years. And in today's talk, we're going to be looking at artificial intelligence, obviously, an extremely topical subject around the world right now. And we're going to be looking at, is it a fad? Is it a fabulous thing? How does it affect technology? Um, and to see whether or not it's something that's of interest to you and interest to your business. It's obviously having a tremendous impact around the world, and we just thought we would share 20 to 30 minutes of our thoughts on this, things that we've seen from the marketplace, how things are affecting, how AI is affecting the marketplace, and what we've seen from our experience with it. So in terms of just a bit of an agenda, things we're going to be looking at, we're going to be just giving a bit of a brief history of artificial intelligence, how one can understand it, um, why we believe that 2023 has been AI's breakout moment inside the marketplace, and probably hold a little bit of a contrarian position there. Um, Provide our thoughts on how we see businesses using AI effectively. I think critically, there are a lot of businesses that are trying to make AI work. They're worried about the threat. And so we've got some thoughts in terms of practical experiences we've seen with our clients, that we've also seen people approaching it from probably a little bit from the fad and the hype cycle side. So we'll be exploring that and ultimately coming to our position as it is right now in August of 2023 around how we feel about AI. Do we believe it's a fad or fabulous? But as I said, kind of starting off with just a little bit of a history of AI. Um, as computer scientists, as software developers at Full Stack, we're obviously very interested in where we've come from, in terms of where we are right now and where we're going to go. And I think AI, if one considers the rise of computational machinery in the early 20th century, almost before we figured out whether or not we could compute with machines, we were already imagining a world that we would be able to, once we can make a machine that can compute, that we would be able to make that machine compute at a sufficient level to um, be intelligent, or at least impersonate a degree of intelligence. Critically, there, as you can see, that science fiction underpinned a lot of the early thinking. One has to almost artistically imagine something before it becomes part of your lived reality. But notably, there as well is that whether those early science fiction authors, they wanted to see AI become something that was important. They believed that by 2001, the famous example of Arthur C. Clarke, that we would reach a point where machines with intelligence would exceed human intelligence. And that has been kind of, Minsky in the 70s at the MIT AI lab also believed, we're just 5 or 6 years away from a point where that kind of intelligence is going to be able to be mimicked. And that continues to be the case. And so AI has been something of a mirage on the horizon for computational scientists for a very long time. And so, critical question now, as commercial consumers of software, of digital experiences, is: are we reaching a point now that is practical, or is it in fact going to be just another chimera? We look at this photo right now. I think most people would know the man on the right, Albert Einstein, um, discoverer of general relativity, special relativity. But the man on the left, Kurt Gödel, philosopher, mathematics, mathematician, had a very important role to play in the development of computational science, both from the perspective of um, the capabilities in terms of, can we actually compute things reliably? And Gödel is famous for his incompleteness theorem. Why do I mention this? I mention it because a critical question that has underpinned AI all through its history is: can it in fact be done? And possibly something that's not broadly understood outside of the computing sciences is that we actually have ways and means of figuring out whether or not certain problems can in fact be solved with the formal languages that we create. And the discovery and the uncovering and the confirmation that in fact some things cannot be solved with formal language systems was a critical catalyst for the creation of computing machinery in the first place, to get the kind of capital from governments, from business to invest in computers required certainty that we would know what classes of problems we could solve with computers and the ones that we couldn't. And that's something important to understand, and it'll come into some of my arguments a little bit later. So critical influence on Alan Turing, the father of modern computing and computing machinery, was Bertrand Russell, Nobel Prize winner of literature. And he explored this mathematical phenomenon of Russell's paradox. I am a liar, this statement is false. The kind of the loopbacks that and recursion that can create logical problems, the paradoxes that are contained within inside of all of that. And this speaks to incompleteness, because it speaks to the mathematical problem again, that we can describe with formal language systems that are not viable. To us as people, that's intuitively true. We all enjoy fiction. We can imagine and express using language conditions and examples that cannot in fact be proven. We can describe unrealities. And why is that important when we think about artificial intelligence? It means that before we embark on large capital expenditure now into bringing artificial intelligence into our businesses, we have to ask ourselves the question, is this in fact going to give us what we think it's going to give? In a small town where every man's clean shaven, there's only one barber. The barber shaves all men who do not shave themselves, and only men who do not shave themselves. Who shaves the barber? How can it be that the barber is clean-faced when he's the only person who can shave it and he can't shave himself? These are the paradoxes that mathematically can emerge. And so an important question is, are we living in a paradoxical context with AI? So as I mentioned, Alan Turing, the founder of modern computing machinery, famous for the development of the bomb, it was called, at Bletchley Park in the UK, conceived of a machine with infinite information would be capable of being computationally complete, that in that computation it would be able to infer and solve any deterministic computable problem. And that's important. We remember Gödel a moment ago. A computer is not capable, by its very mathematical nature, to solve incomplete problems or unsolvable problems. At the same time, we as users of computers feel that they're so magical. Their sheer computational complexity and capability implies that almost any problem can be solved. But at the outset, these machines that we today call computers were never designed to solve every single problem, not to deal with every single general problem. So a critical question then emerges: is AI a computable problem? In fact, the Turing machine is a mental experiment, and we talk as computer scientists of Turing complete machines. It's what enables us on a modern computer to play the same games that were used on a computer 30, 40 years ago. It's because of Turing complete languages. However, the computers that we use are in fact von Neumann machines, not Turing machines. And the model that we can see on the screen now, it should be familiar to all of us. We have an input device, we have a mouse, we have a keyboard, maybe we have a microphone, maybe we have a camera. And this enters the computer. The computer processes that information, it applies control, it performs some arithmetic or mathematical logic, it can read and write memory, maybe a flash drive, maybe flash storage, maybe a hard disk, maybe a floppy disk, and then it outputs to the screen, or it outputs into audio, it outputs into some sort of sense perception that we can use as people. So critically is, Turing provides for us a theoretical and mathematical framework, and Neumann actually created and designed a model of computing that has worked very, very successfully for the 20th century and well into the 21st century. The critical thing here is that because of the phenomenal success of the computer, the von Neumann machine, in our contemporary society, we have some secular misunderstandings of computation, that were we to get into a time machine now and travel back to the past, to those people, it would seem completely and utterly ridiculous to potentially have some of the assumptions that are underpinning the excitement around AI today. Firstly, there's some scientifically misplaced assumptions. The assumption that all problems are computable, we have known for over 100 or nearly 100 years that not all problems are mathematically computable. Secondly, the idea that all problems are deterministic, i.e. reliable. We also know that that is not true. And that, maybe a topic for another day, speaks to the rise of quantum computing, which can explore things like superposition and non-deterministic computation. So, so if we are moving forward on the assumption that every single problem in the universe, including the problem of intelligence, can be computed with a deterministic computer, i.e., a von Neumann machine, we are making a bad misunderstanding. We've got a misplaced assumption. Technologically, as well, there are some interesting things for all of us who have really lived in the last 60 to 80 years. We've lived on a curve in which computing power has become increasingly more powerful at a lower cost. And that's led to that exponential increase in computing power has seemingly led to exponential increases in technological utility. So we are all conditioned to believe that with every passing year, the utility of what we're experiencing is going to improve. For those of us who lived during the time where we moved from feature phones to smartphones and from keyboard phones to touchscreens, we saw a dramatic change in the technology of phones. But then any of us who've upgraded a phone maybe in the last 5 or 6 years, yeah, maybe the glass has gotten a little bit bigger, maybe the phone's gotten a little bit faster, but fundamentally, we are not seeing a situation where there is a radical improvement in the true utility of a phone. A phone from 6 or 7 or 8 years ago is not going to do something significantly inferior to what a phone now would do. And so we have a misplaced assumption in that just because we're creating bigger and bigger computers, we're going to land up in a situation in which advanced technology, where things are just better. And we go back to our science fiction writer, Arthur C. Clarke. Any sufficiently advanced technology is indistinguishable from magic, the Clarke's laws, the third law. The problem there is that because we have had sufficiently advanced technology arriving fairly consistently for the last 50 to 60 years, it's very easy for us to start applying that magical thinking. And there's a risk, certainly, in AI that has become the norm, that people are expecting these sort of radical improvements of technology. And so we must ask ourselves, is in fact that going to happen? So now we've got a little bit of a context. We've come from the starting of computing. We've understood that then some problems can be computed and others can't. And now we have the fundamental question, why now? Why is this a breakout moment? And if we look at that picture right there and try and consider the size of the cars for scale, we're looking at Microsoft's data center in Quincy, Washington, the United States, the fourth largest data center in the world, consumes about the same amount of power as New York City on any given day, has multiple power plants that are supplying it. It is a gigantic Azure data center. And that kind of speaks to possibly something of a bit of a cynical view here. Is, there we've got the peddler off to the left. We have lived in a time now where there's been immense capitalization by the likes of AWS, Amazon's cloud provider, Azure, Microsoft's cloud provider, Google Cloud, to provide huge amounts of capacity. And that's a good thing. I mean, Full Stack uses cloud technology every single day. We've been a cloud-first business for the last 9 years. So hardly ragging on the cloud. But it's important to understand that these businesses require workloads to occupy these platforms. And they're obviously competing with one another very actively. And we've also seen the technology the cloud is from the outset being commoditized technology. And as it's become better understood, DevOps people are constantly looking to lower costs. There are some workloads that increasingly can be brought into infrastructure that businesses control themselves. So the question, or one of the challenges that exists for cloud providers, is how can we create workloads, useful workloads for businesses that are of sufficient scale and complexity to be essentially unself-hostable, i.e., can you create a protective economic moat around some of the technology? And you can see, for example, with Microsoft's partnership with OpenAI, they want that partnership. They're willing to invest billions because they know that there's such a thirst for AI technology that they can, by putting those computational problems on their cloud, it becomes scarcity that they can use to sell their infrastructure. We saw this about a decade ago with chatbot technology, which was expensive, it was underwhelming, it was very little utility. And we run the risk now of kind of entering again another phase of new wine in old skins. This is the hype curve from 2021 from Gartner around artificial intelligence. And I want you to just, we look at the little arrows down there, particularly in the trough of disillusionment with chatbots, which apparently in less than 2 years we're going to reach a plateau of productivity. Now remember, this is 2021. Now, if we flick forward and we look at this year's hype cycle, just released now at the end of July, where are chatbots? Gone. We should have been, based on Gartner's projection, expecting to see them off in the plateau of productivity, and maybe they're there. But because of the term ChatGPT, we have landed up in a situation where what is actually peak hot right now in terms of inflated expectations is generative AI at the top. When we look at the innovation trigger, peak of inflated expectations, and we look at the absolute turning point, there we see generative AI riding out and driving out that heat point. So notable that the thing that when some of the cloud providers in their last cycle 10 years ago were going, we need workloads, we're going to bring chatbots, we're going to change the world. Remember, I think we all saw the Google talk where there was haircuts being ordered and the agents were all going to just talk to one another and we wouldn't have to do any work. There are some similarities to how generative AI is also offering this panacea where essentially we as people just operate godlike in the world and artificial intelligences do all our work for us. Would be nice. Of course, the technology that underpins generative AI are large language models. It's outside the scope of this discussion to get into too much technical detail, except to say that language models have been around for a very long time. I mean, a language model is essentially the probability distribution curve of a word and what is the most likely next word. And of course, any of us who were using a Nokia phone 10, 20, 25 years ago, when predictive text arrived, would know what a language model is. Got a little bit better, and we entered the world of dumb autocorrect with our iPhones and with our Android devices, where we found, the language model got a bit bigger. It could sit inside the phone. It could be more predictive, but it ultimately still made mistakes. Now we live in a time of immense language models, where we can again send a sequence of terms and the language model can use to extract out and provide the most probabilistic response. It raises a lot of questions, ethical questions around content consumption, who's the author of these things, and so on and so forth. But technologically speaking, and speaking as full stack, coming from a technology point of view, it's a language model. It's a large language model. And therefore, it's very attractive for a cloud provider to say, well, I've got a tool that can only really work if you're buying my product. It's the old the whole handles and razors story. The razor is AI. The handle is the cloud. And so we're going to see a lot of competition around this. But I think that what is different is that we can see that there's also a tremendous amount of utility in these tools. So the question then becomes, how can businesses use AI effectively? How can a business reach a point where it's able to get what it needs from artificial intelligence? And I think it's important to sort of triangulate artificial intelligence as a field. Machine learning, which is neither learning and doesn't involve a machine, but is one sort of subset within inside artificial intelligence. And then critically, the thing that has caused a dramatic level of excitement has been natural language processing. And that speaks to also our desire as people to be able to talk to a computer and have a computer talk back to us. And so I think those improvements in terms of natural language processing are one of the areas where businesses can see a lot of growth, because those tools, there's so much natural language being spoken. The arrival of the pandemic, transcriptions in Teams and Zoom, all of that is supporting this broader world of digitized language that can inform and can be useful for businesses. So, if we go back to Shakespeare, what's in a name that which we call a rose by any other name would smell as sweet. To paraphrase, I think we can effectively say that, whatever we call an algorithm by any other name would be just as useful. So whether you want to call it artificial intelligence, whether you want to call it machine learning, whether you want to call it natural language processing, large language model, fundamentally what we are talking about is that there's a new class of tool, a new technology that we can use as business people, as technologists, that can be extremely beneficial to us. And so our advice as full stack to businesses is focus on automation and focus on the artificial elements of the artificial intelligence equation, not the intelligence. If you're worried about general intelligence or the rise of the machines, there's very little, possibly that is impossible, computationally speaking. What businesses should be doing, in our opinion, is to enable large language models there have been incredible natural language processing algorithms that have been developed, and they're readily accessible. So rather than thinking about generative AI as the magic, that's just the prestige. The real key here is to recognize that the editing and the condensing and the extracting, not the generating of content, is going to be the essential tool in our world in which the cost of generating information trends to zero. I mean, we're all worried about this deluge of excrement that could be potentially produced by generative AI that has not been sufficiently edited by people, that has not been sufficiently, our haystacks are getting made so much bigger and our needles are staying the same. So the ability to use the tools that are capable of processing all of this text and all of this generated content is critical in terms of the utility of AI, in our opinion. And we don't believe, as I said, that you should buy the hype around intelligence. We've always improved tools as human beings. It doesn't necessarily lead to the tool overcoming the utility. We can fly in planes, but we can't fly without them. And so I think that some of these fears are misplaced. So the question, is it fad or is it fabulous? What is Fullstack's position on artificial intelligence as it stands right now? So number one is we believe that AI is going to be essential to business to remain competitive. So as part of our mission, we believe that every single business in the world is going to become a software business. So fundamentally, it follows then for us that there is no way in which a business is going to be able to compete without actively engaging in what we would term AI, or largely automation, and large language models impact on business. Much in the same way the rise of digitization, internet, just the use of desktops on every single computer, on every single desk in the workplace. This is an inescapable force, and I think we can all acknowledge that. Critically there, and I think this is important, not just to calm people down, but just to get a proper understanding of these factors, is it's not magical. It's simply the latest and along the line of known computation tools. The unknown, the unsolvable, I think some of the excitement that people have is probably going to be more likely to be delivered by quantum computing, because that will start to deal with non-deterministic outcomes. Our third element is value extraction from the content generated is going to be far more valuable than content generation itself. Microsoft is going to be going live with Copilot. It's already beating it with many clients, and that's going to lead to hundreds of millions of people in the world being able to generate large amounts of content on the basis of the content that their organization already contains. I think it kind of follows quite obviously what the problem with that's going to be. We're all going to be able to create voluminous amounts of content for other people to then have to consume, and they're not going to. And the probability then of the signal getting drowned out by the noise is greatly increased. So when thinking about artificial intelligence, it becomes very, very important for a business to think about how are we going to then be able to extract what is coming out of not only our artificial intelligence tools, not only our generative tools, but also the generative tools of our competitors, of our colleagues, of our vendors. And so value extraction out of content becomes more important than content generation itself. And another part which we've kind of looked at today is the fact that there are large-scale economic incentives that drive these AI costs. So it is not simply a technology that is not going to bear with it a tax. And what I mean by that is, I mean that many of these technologies are not going to be able to be brought into the premises. They are going to have to be cloud delivered, and they're going to have costs associated to that. And so modeling the price of bringing AI into your business is going to be something that's important to establish of, is the juice really worth the squeeze? Do you have the problems that need this tool to solve? Much in the same way as any other software problem requires that ascertaining, is this expenditure justified? Fifth element of our position, to maximize the utility of the new tools, there has to be deep technological understanding and execution. To understand this is to execute well on it. And that's why we wanted to do this talk today, is because if people can understand the where this has come from, people can understand what the economics behind it are, and people can understand where it can help your business, then people can make the right kinds of decisions around artificial intelligence technology. So in conclusion, from our side here, automation, and let's call it artificial execution, is here to stay. It enables business to be more productive if we use to filter as well as generate. The code and the API capabilities of embedding AI go a lot further than OpenAI and consumer tools. I think this is an important thing for people to understand. This is not something that is purely limited to ChatGPT. These large language models, there are lots of large language models that are becoming available, and also the capability to develop your own and deliver it via the cloud is increasingly being democratized. It is without a doubt that we are moving through an extremely fast hype cycle on generative AI and large language models, and it's quite possible that it's a bubble. But I think the important thing to understand here is that post that bubble, some real utility will remain. If we think back to the chatbots that I spoke about from a decade ago, there are many businesses in select areas that have found tremendous benefit to those chatbots, lowering servicing costs, allowing people to be serviced 24 hours a day. So it's not to say that these technologies are not going to have phenomenal utility into the future. So yeah, if you need more, if you want to have a little bit more of a conversation about artificial intelligence, about large language models, about how maybe your business can bring more AI into your practice, or if you're already using AI and you're not seeing the results that you're hoping to, that your projects have got pain points, please don't hesitate to contact us at Fullstack. Myself and Hercules, the two shareholder directors of the company, along with Janelle, our fellow director, are always keen on listening to businesses, hearing what they're struggling with, and hearing about where they are on their transformation journey. So with that, I just want to thank you for half an hour of your time. It's much appreciated, and we definitely look forward to more of these conversations in future. And please do reach out to us. Thank you.